Okay, class, today we're going to look at this idea of functions defined by equations. Now, our key word today is function. Now, we did a lot with functions last year in pre-algebra. I don't know if you remember, we had those little Foreman function where we figured out the rule, and we always had to write the rule. It said write the rule, and we always had f of n equals something. So we did a lot with it back then, but let's look here at our definition. A function is a correspondence between two sets. The domain, okay, the domain is usually our input, okay, and we know it as the x values, and the range, which is our output, which we know as the y values. And here's the key. It assigns to each member of the domain exactly one member of the range. So if you notice when you look at my little mapping chart here, there is exactly one arrow from every number in the domain to one number in the range. So basically what that means is you can't repeat your x values. Okay, you can't repeat your x's. Okay, it has to be one-to-one correspondence. And so that's what we saw as we went through here. Now, if you look here, I've got my input, my output chart for the idea of the number of tickets sold. So if we were writing the rule, we're worried about the number of tickets sold. Okay, and so that's what this little mapping chart shows us. Now, once we get those mapping charts figured in, we can take those ordered pairs that we're going to get. We got the domain, and again, if you see my domain down here at the bottom, we've got the range. We can put the domain with the range in corresponding entries, and we come up with a set of ordered pairs. And that's what you see I did here, okay? Basically, I had a set of order pairs, and if we took these and we graphed them, okay, let's see, if I graphed 2, -40, that's going to probably be about right there, pretty close. If you notice, I'm counting by tens. And if we did 20 and 50, well, that's going to be about there. And we'd see that 0 and 10 is about there. And so we could see then if I took those points, my domain and range, and plotted them, we would have the graph of a line. Now, what we're really concerned about in section 8.7 is this idea of function notation. Okay, function notation. So, this is P of n. They're going to actually name our functions. They name them by giving them letters. So this says the function P, the variable involved is n, and then this is my equation that goes with function P. Now, you can also see they use arrow notation as well. Once again, my function's name is P, the variable involved is n, and the equation that goes with function P is 5n minus 50. So basically just seeing the whole plan put together. I did my domain, I found my corresponding range, I took those, I made a graph, and then we looked at the graph and we wrote the rule. And that's what we did when we were back in chapter 7, okay? When we were back in chapter 7. Back in 7th grade in pre-algebra. So let's see what that's going to take into account here for us, okay? If we look here, they're going to give it to us, and they're going to want us to write the answer. So basically, if you look here, I've got my function. The function that they've given me is function h. The variable that's involved in function 8 is b, and this is the equation that goes with function h. And then they gave me the domain. Now notice they gave me the domain as a set. So however many members or however many numbers are in the set is how many times I have to do the math. So if we look here then, we've got h, and they want me to find h of 0. Well, we're going to plug in 0 every time I see b. So we've got 0 squared plus 3, and that's going to give me 3. Now we've got to find the function at 2. So my function h at 2, we're going to plug it in for b2 squared plus 3, and that's going to give me 7 when you do the math. Now we have to also figure out what happens if I plug in a 4. What's the range if the domain is 4? So h at 4, we're going to get 4 squared plus 3, and that's going to be 12 plus 3, which is, actually 4 squared, 16 plus 3, which is 19. Now, if I give you the answer in a set, my range has to be in a set, so you would say 3, 7, and 19. So that is my answer. Okay? Now, let's look at number 2. Well, on number 2, the function is named m, the variable involved is x, and this is the equation that goes with it. They gave me my domain as a set. There's 3 numbers in my domain, so I have to do the domain 3 times. So let's see what happens when I do m of negative 1. Well, we're going to take the first number in the domain. We've got negative 1 squared, okay, plus 5 times negative 1 plus 2. All right, so if you're looking there, then that means I have 1 minus 5 plus 2 when I do the math. And so my final answer there is negative 2. Okay, now let's find the function. What's the next member of the domain? Negative 2. So we're going to find the function at negative 2. So I've got negative 2 squared plus 5 times negative 2 plus 2. Well, negative 2 squared is 4. 5 times negative 2 is 10 plus 2. So what's my final answer? Well, that's going to give me negative 6 plus 2. So the final answer on that one is 4. Now, I've got the third member of the domain. If I look, my third member of the domain is negative 4. So we've got to find m at negative 4. So I've got negative 4 squared. Remember, wherever I see an x, that's what I'm plugging in negative 4 for. Plus 5 times negative 4 plus 2. Well, negative 4 squared is 16 minus 20 plus 2. Negative 16 minus 20 is negative 4. Negative 4 plus 2 is negative 2. Now, this time, did you notice I have a repeated answer? So when I'm doing my set, the range is negative 2 and negative 4. If we have a repeated answer, we only have to put it in the set once. Okay, so little recap. If they give me my function with my domain as a set, my answer has to be a set. Now, let's see what happens on the next slide. If you notice, this time, they gave me my domain in function notation. Okay, function notation. So if you notice here, I have to do the math three times for a. Remember, this is function m. The variable involved is y, and this is the equation. So when I go to letter A, wherever I see a y, I need to plug in negative 1/2. So this is what it's going to look like. We have negative 1/2 for the first y, and then in parentheses, we have 1 minus 2 times negative 1/2. Now, you got to be careful with the math here. What's negative 2 times negative 1/2? Well, negative 2 times negative 1/2 is positive 1. So this becomes 1 plus 1. So now I have equals negative 1/2 of 2. What's negative 1/2 of 2? Yeah, that's negative 1. Now, here's the key. If I give you the math in function notation, my answer needs to be in function notation. So here we would say function m at negative 1/2 equals negative 1. Okay, and that is my answer. Okay, because they gave me the math in function notation like they did here in A, my answer has to also be in function notation. Now, let's go ahead here and let's try the second. Let's do letter B. Once again, the function at m, we're going to plug in 1/2 for y. So here we go. Let's look at our math. Well, we've got negative 1/2 for the y outside the parentheses, and then we've got 1 minus 2 times 1/2. Okay, so let's do the math in the parentheses. That's what order of operations says. What's negative 2 times 1/2? Yeah, that's going to give me 1 minus 1. What's 1 minus 1? 0. What's negative 1/2 times 0? 0. So in function notation, okay, we would get that equals 0. Look at letter C. What's going to happen on letter C? Can you figure it out? Yeah, function m, we're plugging in 0 for y, and hopefully you realize that would be 0 as well. Okay, let's go to the other side. Our function this time is called capital N, so my function is n. The variable involved is t, and this is my equation. So let's go ahead and do the math. I'm going to look at letter A. We're going to plug in a 3 for t. So I'm going to do the math over here. We've got 3 cubed minus 27. Well, what's 3 cubed? Yeah, that's 27. What's 27 minus 27? 0. So in function notation, there's my answer, final answer. Let's look at letter B. We're doing function labeled n, and we're plugging in a negative 3 for t. So now I've got negative 3 cubed minus 27. What's negative 3 cubed? Yes, negative 27 minus 27. So this equals negative 54. And once again, my answer has to be in function notation since that's what I started with. All right, now let's look at letter C. Again, we're dealing with function n. We're plugging in 0 for t. Not all automatically 0. Let's see what happens. We have 0 cubed minus 27. So when I look at the math, what's 0 cubed? 0. What's 0 minus 27? Negative 27. Making sure that our answer is in function notation. Okay? Function notation. Now, our next slide is real important, okay? And hopefully I can get you to see right away what we need to do. When we get to the next slide, they actually have an A part and a B part. And if you look, it says for each function, well, on letter A, they want me to find f of 0. So remember, we're looking at function f. This is function f, that's its name. Okay, the variable is x, and I'm plugging 0 in for x. So what happens if I do that? Well, we've got the function at 0 equals 4 times 0 plus 7, and some of you could have figured that out without me writing that. So the function at 0 equals 7. Again, my answer for letter A is in function notation because that's what they gave me. Now, if you look at part B, they want me to take the whole function. You notice it says f of x, and they want me to take the whole function, 4x plus 7, and make it equal 0, and then they want me to solve that. Well, we're back in chapter 3. How do we solve an equation? Isolate the variable by inverse operations. So we're going to subtract 7 from both sides. So now I have 4x equals 7. Now what do I need to do? We need to divide both sides by 4. Again, I had to make that negative 7. So x equals negative 7/4. Now usually when they have us do this, we put our answer in set builder, but I'll take either one. So do you understand the difference? So this is my answer for B. For letter A, when they want f of 0, we're just plugging in 0 for x. For letter B, they want us to take the whole function and make it equal 0 and solve. So how are we going to do that for number 2? Well, let's go ahead and take care of letter A first. Well, letter A, they want the function at 0. So that's going to give me 3 minus 1/2 times 0 when I plug in my x. So the function at 0 equals, yeah, that's 0, equals 3. Now, what's going to happen on part B? Remember, part B, I'm supposed to take the whole function, okay, the whole function. which is 3 minus 1/2 x, and make it equal 0. All right, so how are we going to isolate the variable? By inverse operations. Yeah, we're going to subtract 3 from both sides. So I have negative 1/2 x equals negative 3. Now, how do I get rid of that 1/2 in front of my x? Yeah, multiply by the reciprocal. So we're going to multiply by negative 2 over 1. So those cancel. What I do to one side, I do to the other. So here, x equals negative 2 times negative 3, which is 6, or you could put it in set builder 6. Okay, so making sure you know what to do when on each part A and part B. Now, last thing we need to look at is this idea of putting functions together. Okay, let's look at the top. Number one, they told me that my function is f. It's labeled f. Okay, the variable is x, and this is my equation that goes with f. So when I get to number 1, they want me to find 2/3 of f of 5. So what do you think I need to do first? Yeah, remember f is this guy right here, so we've got to find f of 5. Well, f of 5 equals 3 times 5. Remember, they're telling me plugging in 5 for x minus 1. So what is my function at 5? Well, that's going to be what? 15 minus 1, which equals 14. Now that I've figured out f of 5, I need 3/2 times 14. Okay, Mrs. Burton forgot to put her 1 up there when she wrote 14. Okay, so now what's 3/2 times 14? Well, that's going to equal 21. Good job. Now, what happens on number 2? They want me to figure out f of 5, and they want me to figure out f of negative 1, and then they want me to add them together. Well, we just did this part on number 1. So what is f of 5? Remember over here, that's 14. What happens when I plug in negative 1, when I need to find f of negative 1? 3 times negative 1 minus 1. That's going to give me negative 3 minus 1, which is negative 4. So f of negative 1 is negative 4. And now, what's 14 plus negative 4? 10 is my final answer. Now, last thing we're going to look at is this idea of composite functions. Okay? Now, kind of crazy, if you look at number 1, it says that I have g of f of x. Okay? g of f of negative 2. So basically, when we're doing these composite functions, we start on the inside and work our way out. So we're going to start with f of negative 2. Well, what's my equation that goes with f? X squared. So we're going to get negative 2 squared. Okay, I just plugged in negative 2 in this equation. Well, negative 2 squared is 4. And now they want me to figure out g of negative 4. Well, we've got to go over here and look at the g equation. And so that means it's 2 times x. So what's 2 times 4? 8. So g of f of x equals 8. Now, we're going to do the same thing on number 2, except we're going to start with g of x. We start on the inside and work our way out. So we go back up here to g of x, so we're going to have 2 times negative 2. Well, 2 times negative 2 is what? Negative 4. And now that I've found negative 4, I've got to go back and find f of negative 4. Well, now we got to go back up here to our f equation, and we've got negative 4 squared, which is 16. Okay, so again, those composite functions, we may have to start on the inside and work our way out. All right, what to do when is the most important thing, so we'll check homework tomorrow.